EcoCompass is a simpler comparative tool that enables the performance evaluation of existing product with a developing one. Unlike LCA, which calculate the environmental impact of a product by the input and output at the individual stages, EcoCompass quantifies impact based on 6 dimensions. These are assessed to identify significant environmental and economical issues relating to a product throughout its life cycle. The score allocated is based on the percentage increase or decrease in performance. The outside boundary of the diagram reflects an ideal eco-profile. Mass intensity refers to the physical mass of the product and any additional mass of material consumed and disposed. Energy intensity captures the change in energy consumption associated with the product. Health and environmental risk detect the change in the environmental burdens associated with the product. A series of indicators, such as the one shown above, can be used. These are scored individually and totaled for the final score under this dimension. Revalorization of waste relates to a product value at the end of its life. A higher rating is allocated to a product whereby the material can be converted into other useful product instead of a direct disposal. This can be done through recycling, remanufacturing and energy recovery. Nature, and the renewability of associated material and energy for the product is the key focus of resource conservation dimension. The effect it has on biodiversity is evaluated as a whole and contributes to the overall score. The service extension of a product goes beyond the literal meaning of prolonging the product life. It can be interpreted to mean extending purpose of use of the product. Thus, increasing the score of this dimension can be done through various means as above. To obtain a better understanding of how these dimensions are scored, we will do a simple case study. Based on the data accumulated and with valid assumptions, scoring for product B is carried out. The score is relative to product A, which is taken as the base case and given a score of 2 on all dimensions. The resultant EcoCompass diagram is shown in figure above. From the example, the strength and limitations of EcoCompass can be evaluated. EcoCompass is able to present a holistic overview on the performance of the designed equipment or processes. Identifying area of improvements is made simplified as it is broken down into the different dimensions. With a stretched scoring range of 0–5, the extent of performance improvement is made clearer. In addition, the visual representation of the result allows for the straightforward comparison of the two products. While there are many advantages to using EcoCompass, there are limitations to the tool. One major problem lies in obtaining a comprehensive life cycle data. Due to the lack of resources and complexity of the LCA, data often falls short in depicting the true environmental performance of a product. Due to the unavailability of a standard scoring guideline for the different dimensions, the scoring is dependent on the designer's evaluation of the product. Lastly, the lack of transparency to the score allocation presents credibility issue of the scoring. Many experiences suggest that sustainable management can offer competitive advantages in cost reduction, design innovations, performance improvement and attract new customers. However, utilizing the right set of tools is of utmost importance in improving sustainability of a product or process.
Created using Part2.